Hi, good morning. Sorry about the delay. I think he just said that I'm doing this without speaker's notes, but in case he didn't say that, I am doing this without my speaker's notes. So I apologize if I lose my place at some point. Okay, wait, before we start, since I was waiting for so long, I thought maybe I would give you all a joke. Did you hear the one about idempotence? Yeah, but that joke was only funny once. All right, so hi, my name is Ann Harter. I'm here to talk to you about how there is no magic on the internet and encourage you to write your own HTTP server, which you should then absolutely not use. Really quickly, a little bit about myself. I'm a new developer. I'm an alum of Recurse Center, formerly known as Hacker School. Hacker School has been best described as a writer's retreat, but for programmers. It's an inclusive space. If you guys are in any way interested or curious about Hacker School or Recurse Center, please come and talk to me afterward. In a previous life, I was a research psychologist. I studied personality, motivation, and aesthetics, and I am very nearly employed, just not at a place where I can make an announcement, but if you're curious about that, you can ask me later. So a quick overview. There is no magic. We're going to talk about how the internet works. The client sends a message to the server, and the server responds. We all know this. There's the magic way that that happens, that we're all used to, and then there's the not magic way that that thing actually happens. I'm going to show you what's called an echo server, which is based on a 30-year-old protocol. And then we're going to get into the reason that I'm talking, the HTTP server. And then we're going to take a step back and talk about why we shouldn't use that. I promise cat pictures the entire time, or most of the time. So this is how the internet generally works. You sit down at your computer, and you'd like to see a cat, and you know in the back of your mind, because you're a savvy developer, that your browser, the client, sends a message to the server, and the server responds with a cat. And it's magic. You have cats. Except it's not magic at all. This is what it looks like. This is just a screen cap of my terminal when I ran netcap on google.com on port 80 right there. And then you can see the actual GET request that I sent to Google servers. I queried for cute kitten. And that was followed by the response headers, which are verbose, and the response body, which, if you guys can see from back there, is obviously just a bunch of HTML, which, of course, your actual browser interprets for you and makes look really pretty. So, the echo protocol. Now that I've overviewed how the internet sends you things, let's take a step back in the pre-internet days and talk about this RFC from 1983. So it was built, I think, as a debugging and measurement tool to be used by sysadmins. And it's very short. This is the entire protocol. And in fact, only one small part of it actually matters. In case you can't read it there, it says, one echo service is defined as a connection-based application on TCP. A server listens for TCP connections on TCP port 7. Once a connection is established, any data received is sent back. This continues until the calling user terminates the connection. Basically, the client sends a message to the server, and the server echoes it back. The connection between the two stays open until the client closes it. This is what the code for that looks like. It's just as brief as the protocol itself. I required the socket library, fired up a TCP server on port 7, and then the meat of the code, which there isn't much of. Once the connection is made by the client, the input from the client is saved as a message, and the server echoes it back. This continues forever, while true. This is what it looks like if you actually run it. This is actually running on my server. If you guys are there with your laptops and you're really bored, you can connect to my server, peaches.co, on port 7, and you'll be met with an empty prompt. And you can type whatever you want there, and it will respond with whatever you want. There is, as you saw in the protocol, no logging. You can say anything that you like, and it'll say it right back to you. So the first message of any pair is just the message that I sent to the server, and then the second message is what's echoed back. You can even see the escape where I close the connection. So with that in mind, right, this very basic idea of how the client sends the message to the server and the server responds, we get into HTTP. So HTTP is very long. It's about 90 pages. It's very dry. It's extremely particular in the mays and musts of things that you can and cannot do. And it's absolutely amazing. All of the things that you sort of know implicitly about how the internet works, it turns out are in this document. It's not some weird thing that your browser does. Your browser does it because this document told it to do that. So it's 90 pages long. I won't go through the entire thing, but I'll sort of cover some of the basics. HTTP operates under HTTP verbs for requests. Basic ones, everybody's familiar. I hope you're familiar, maybe you're not, with get and post. Get just gets the requested file that the client is looking for from the server. Post will send new information up to the server. Put will update information, and delete will get rid of it entirely. So we're going to talk about GET requests today, because when we finally get into it, we're going to see the world's most basic HTTP server. This is what a GET request looks like. This is an actual picture of peaches that you can see on my website if you don't have enough peaches in your life. And you'll see the first line of the request says get/peaches.jpg http/1.1. All HTTP requests have to start with a verb and a location and the version number. This is followed by a number of headers, some of which are optional, that I won't go into, but if you're super interested in them, you should definitely read the HTTP docs. And this is what a response looks like. It's the first line. Again, we have the version of HTTP that we're using, followed by a status code, 200 OK. That means that the request was successful. We have, in fact, peaches. After the status code comes the response headers that include, like, as you can see, the date, the content type, which was an image, the content length, which is all of the bytes inside of it, and then that'll be followed by the actual message body, which in this case is a picture of peaches. Real quickly about HTTP status codes, and I apologize if I'm going very fast or very slow because I don't have a timer on here. There are 5 categories of HTTP status codes. The first one, the 100 codes, are informational. Frequently, they are just informing that the connection that there's more information to be sent. The 200s indicate successful connections. 300s are redirections. 400s are client errors, including the infamous 404 file not found. And 500s are server errors. And I realized that as I made this slide yesterday, there's no cats on this page. But if you like cats, and I hear that a lot of you do, you can go to http.cat for all of the cats and status codes that you ever wanted. A cat for every status code. So the thing about HTTP is that it is a very large and very particular document. HTTP servers are complex, and they must do a lot of things. Your first HTTP server, well, you can write it any way you want, but the first HTTP server that I wrote and that I'm going to talk about today is very simple and does just one thing. A cat picture. So we're going to write a simple server that will, when requested, respond with this cat picture. And if the request is not formatted, just particularly, it responds by simply printing hello to the browser. So here's the very simple code for that. Again, as with the Echo server, at the beginning we require socket so that the computer can make system calls. I wrote a very simple function here called send200, which is going to respond to the client's request with a 200 status code, 200 OK status code, and then the content that was requested. And then it'll close the connection. Note that in this code, there are no other status codes. There's no 404. If you request a cat picture that isn't there, the server just kind of hangs. There's no 404 to be delivered because I didn't write the code. And the internet is written by people. So then we fire up a TCP server on port 2015. I chose that basically randomly because it's the year that we're in. If you want to do this, you can choose basically any port you like except above 1024 for reasons that I won't get into in this talk. And then we get into sort of the meat of the code. Once a connection is made by the client, I should look at this one. Once the connection is made by the client, the input from the client, client.gets, is saved in the request variable. If request starts with get, because remember there are many kinds of HTTP requests that one can make, if request starts with get, then we take the URL from that request. Remember when I had the peaches slide up, the URL was /peaches.jpg. We save that URL, and what we're looking for here, when we split it up, is a request URL that starts with /images/. If it does that, it's going to sub that out entirely because I don't actually have a folder in my directory called images. It's not looking there. I'm taking that out completely. I'm just sort of doing that so that people who visit my website can see that I keep images under the images slash. So the images directory, excuse me. And then the picture itself that's being requested, cat4.png, which we'll see in a second, is then opened up, saved in picture, and then the send200 function is called with the picture, and it's returned to the client. If none of those things happen, we respond simply with hello. So you can see there's my request. It says, so I run this on localhost, as you can see. Images/cat4.png, that just happens to be the name of the file. So how does this work? So as I said before, if the URL starts with /images/, because that's the way I wrote the code, just in the same way that all code is written by the whims of the programmer, then we sub out /images/ with an empty string, taking it away entirely, and we look simply in that folder for something called cat4.png. And it's great, it works. You can run this, if you write this code yourself, and you run this on localhost, and you can pull up the cat, and you're very excited, and you go and tell your friends, and you can't wait to show them because, oh my God, you just built a tiny slice of internet with your fingers. Except that this is the part of the talk where I tell you not to do this. So you should do this for your own edification, but be very careful about your friends. So this is a true story. This talk happened because I did this. I wrote this code, and I got very excited, and I went to show my friends. And my friend Ken sat down with me, and he was very excited for me and very impressed, and we high-fived, and he pulled my keyboard away, which, by the way, never let your friends touch your keyboard just in general. He pulled my keyboard away, and he started typing. And something like this happened. So my server was still running, and as you can see, the request, as you see up at the top, so we have localhost port 2015 /images/, and then a whole lot of stuff that isn't cat4.png. So you will recognize, and of course, it says right there. That's my public SSH key, accessed via the server that I wrote. I pulled this up just for this talk. Except that's not what he pulled up. He didn't pull up my public key, because who cares about public keys? We can all see them. They're public. I'm not going to show you what he actually pulled up, because it's mine. So how did that happen? How did he get my private SSH key so quickly? It was something like this, but not quite. So remember, the code hasn't changed. It's exactly the same as it was before. I wrote some code so that when images/cat4.png was called, it would return the lovely picture of the cat. And unfortunately, this is the day that I learned about path traversal attacks. So remember when the request starts with /images/, we sub that out with an empty string, it's gone, it doesn't exist anymore. And picture, so we have file.read with file is taken as the argument, is suddenly user/Ann Harter /.ssh /ID _ RSA. And the computer doesn't know any better and doesn't care, so it delivers what it's asked for. Bad kitty. So the thing is, if I had had this running on my Linux box up in the cloud, it would have been exposed to the public internet. And it's a Linux, this file directory systems look the same pretty much unless you make special changes to yours, meaning that any old person on a publicly exposed server can take anything they want from you if your server is written poorly. So what is a developer to do? Oops. So this is one solution. This is what I went with. I really like Nginx. I do not work for Nginx. There will be other proxy servers that you might enjoy using, and static file servers. So Nginx, if you haven't used it, is an HTTP proxy server. It's a great static file server. It's what I used early on in the talk when we saw the picture of the peaches. That's actually served up via an Nginx server that I have running. And the nice thing about Nginx is that I'm a new developer, as I said, but one of my friends said you should use Nginx. And I went off and read the docs, and they're really actually very friendly. So I would highly encourage everybody to at least give it a shot or look at it. But seriously, especially if you're a new dev, I hope that you have senior devs who know you and who love you and who you trust. And you should ask them what they like to use. OK. So if you shouldn't use the code that I just encouraged you to write, why bother? Because the client sends a message to the server and the server responds, which we all know in the abstract, but I hope that as I sped through this talk, you all got a chance to sort of get a better idea of. And when you write this code, and when you stumble through it and your whole computer becomes exposed, you start to see and have an appreciation for the off-the-shelf HTTP servers that you might prefer to use. You should use this, though, because you're a developer, because you're a citizen of the internet, and because the internet is written by people, and that's the most amazing thing about it. The internet is strings of text sent from computer to computer, and that is the actual magic. Thank you very much. Special thanks to the RubyConf people who are like, I'm so impressed. Thank you very much for bringing me here. This was so much fun.